Dear students, welcome to my science video channel. In today's lecture, we are going to talk about the mole concept. So let's start with what is a mole? A mole is the SI unit that measures the amount of a substance. And a mole can be related to the number of particles, the mass, and the volume of a gas. So let's look at the lesson objectives. So in this lecture, we are going to use dimensional analysis to convert moles to molecules, moles to atoms, moles to formula unit, moles to grams, grams to atoms, and moles to volume, and volume to moles. So let's summarize what is a mole. So mole is the mass in grams using the periodic table. So if you look at the periodic table here, for example, we have oxygen. So 1 mole of oxygen will weigh approximately 15.99 or 16 grams. So that's the mass in grams using the periodic table. 1 mole is equal to the Avogadro's number of particles, and Avogadro's number is 6.02 times 10 raised to the power 23. And 1 mole is 22.4 liters. So let's start with the first numerical problem. The question is, how many moles are in 3.25 times 10 raised to the power 20 atoms of lead? Pause the video and try solving it. Your hint for this numerical is 1 mole is equal to the Avogadro's number, which is 6.02 times 10 raised to the power 23. So here's the solution. You have 3.25 times 10 raised to the power 20 atoms, and 1 mole is 6.02 times 10 raised to the power 23 atoms. So you divide that. You divide 3.25 times 10 raised to the power 20 by 6.02 times 10 raised to the power 23, and that will give you the number of moles of lead. So the answer is rounded to 5.4 times 10 raised to the power -4. Here comes your next problem. How many molecules are there in 8.3 moles of sugar? So pause the video and try solving it. Remember, 1 mole of sugar will have Avogadro's number of molecules. So the question says 8.3 moles. So 8.3 moles of sugar multiplied by the Avogadro's number, because 1 mole will have 6.02 times 10 raised to the power 23 molecules. So when you multiply that, you will be getting 4.9966 times 10 raised to the power 24, which is rounded to 5 times 10 raised to the power 24 molecules of sugar. Here comes your next question. How many atoms are there in 0.425 moles of sulfur? Remember, 1 mole of sulfur will have Avogadro's number of atoms. So try solving it. You have 4.25 times 10 raised to the power 23 multiplied by 6.02, and that gives you 2.55 times 10 raised to the power 23 number of atoms. Next, how many moles are in 5.42 times 10 raised to the power 22 formula units of NaCl? So you have 5.42 times 10 raised to the power 22 formula units of NaCl. 1 formula unit of NaCl will have Avogadro's number. So you have 1 formula unit will have Avogadro's number. So it is 6.02 times 10 raised to the power 23. So you have 5.42 times 10 raised to the power 22. You divide that by 6.02 times 10 raised to the power 23, and that gives your answer as 0.09 moles of NaCl. Now, let's use dimensional analysis to convert moles to mass. So remember, 1 mole is equal to the molar mass of the element or the compound. For example, let's take how many moles of carbon are in 26 grams of carbon. Now, if you see, 1 mole of carbon weighs 12 grams, approximately 12 grams. So the question is, how many moles of carbon are in 26 grams of carbon? 1 mole of carbon weighs 12 grams. So you have 26 grams of carbon and 1 mole weighs 12 grams from the periodic table. So you divide that by 12. Don't worry about the periodic table. That would be given in the test or in the exam. So when you divide 26 by 12, you get 2.16 moles of carbon, which is rounded to 2.2 moles of carbon. Let's look at the next one. How many grams are there in 2.37 moles of carbon dioxide? Now, this is an interesting one because first you need to find what is the molar mass of carbon dioxide. So from the periodic table, if you see, carbon is 12 and oxygen is 15.99, which is 16. So first we'll try to find what is the mass of carbon dioxide. And the mass of carbon dioxide would be C, there is 1 atom of carbon, so 12 times 1, 2 atoms of oxygen, so 15.99 times 2, and you add them and you get 44.009 grams. So 1 mole of carbon dioxide weighs 44.009 grams. And there are 2.37 moles of carbon dioxide. So 2.37 will be multiplied with 44.009, and that will give you 104.3 grams, which is rounded to 104 grams. Next, how many moles are present in 142.1 gram of sodium chloride? Now, first we need to find the molar mass of sodium chloride. Looking at the periodic table, if you see sodium mass is 22.9, which is approximately 23, chlorine 35.4, and you multiply them and then add them to get the molar mass of sodium chloride. And 1 mole of sodium chloride will weigh 58.443 grams. And your question is, how many moles are present in 142.1 gram? So 142.1 divided by 58.44, and that will give you 2.432 moles of sodium chloride. Next, how many grams are in 3.34 moles of potassium bromide? Pause the video and first try to write down the formula for potassium bromide. Potassium bromide is KBr. Use the swap and drop method. Review my PowerPoint notes on swap and drop method. So you have potassium bromide as KBr. Look at the periodic table, the mass of potassium and bromine, and you add the masses. So you have 39.098 for potassium and bromine 79.904. You add them and you get 119.002 grams. So it means that 1 mole of potassium bromide weighs 119.002 grams. And the question is, how many grams are there in 3.34 moles? So you multiply that, 3.34 multiplied by 119, and that will give you 397.46, which is rounded to 397 grams. Now we'll talk about the molar volume of a gas. Remember, at standard temperature and pressure, 1 mole of any gas occupies the same volume, that is 22.4 liters. So 1 mole of a gas occupies a volume of 22.4 liters. So using dimensional analysis, you would be converting volume to moles or moles to volume. And the conversion factor is 1 mole is 22.4 liters. So here comes your question, determine in volume in liters 0.6 moles of sulfur dioxide gas at STP. Now, 1 mole of sulfur dioxide gas will have a volume of 22.4 liters. So 0.6 moles of sulfur dioxide will have 0.6 multiplied by 22.4 liters, which is 13.44 liters. Next, assuming standard at standard temperature and pressure, how many moles are there in 67.2 liters of sulfur dioxide? So you have 67.2 liters of sulfur dioxide, and you are asked to calculate the number of moles. Remember that 1 mole of sulfur dioxide will occupy a volume of 22.4 liters. So 67.2 divided by 22.4, that gives you 3 moles. Then how many moles are in 1 times 10 raised to the power 3 liters of ethane, that is C2H6. So remember, 1 mole of ethane, C2H6, will occupy a volume of 22.4 liters. And you are supposed to calculate the number of moles in 1000 liters. So 1000 divided by 1000 liters divided by 22.4 liters, that gives you 44.6 moles. What is the volume at standard temperature and pressure of 3.2 times 10 raised to the power negative 3 moles of carbon dioxide? Again, 1 mole of carbon dioxide occupies a volume of 22.4 liters. So you have 3.2 times 10 raised to the power 3 moles of carbon dioxide. You multiply that 3.2 times 10 raised to the power negative 3 multiplied by 22.4, and that will give you 0.071 liters. So this is the conversion table. Remember, 1 mole is equal to the Avogadro's number. So 1 mole is 6.02 times 10 raised to the power 23 particles. 1 mole is equal to the mass from the periodic table, and 1 mole is 22.4 liters. Try to review this video again and try attempting the questions from my assignment.